All right, guys. So most people really struggle with problems like this because they're not sure what to do whenever an angled force is introduced into a situation. So I'm going to walk you through an example problem here and show you exactly what to do to make handling angled forces in a way that doesn't feel super complicated and you can easily integrate it into your net force equations. So we have a person mopping the floor. They're exerting a downward force of 90 newtons angled at 30 degrees below the horizontal. We have a force of friction between the 2.5 kilogram mop and the floor, and that's 70 newtons. So we want to determine the acceleration of the mop and determine the magnitude of the normal force on the mop. So angled forces can trip people up a little bit because they're like, okay, well, how do I get this in here? Is this a vertical force? Is it a horizontal force? And the answer is it's actually both. We just have to break it into those vertical and horizontal pieces. So the first thing that you always want to make sure that you do with any problem, probably almost any problem, but especially ones where you're talking about forces, is draw a free body or a force diagram. So if we're drawing a force diagram here for the mop, we're going to draw the gravitational force. That's an easy one to start with. We can draw this downward angled force, so we'll call that applied force. We have our friction force. We'll imagine this mop is being pushed to the right. And then we have the normal force. And so if you're like, okay, angled forces, what do I do with this? Here's what you're going to do. First of all, if it helps you visually, one thing that you can do here is you can kind of sketch in the two components of this angled applied force. So the applied force is down at an angle to the right. So you have a component of that force that's horizontal to the right. And then you also have a vertical component to this force that points slightly downward. Okay, so we're just going to label those as Fx and Fy. Those are the two components of this force. And just to visualize this even just another way, we can draw this as a right triangle where you have your downward angled force. Here's our applied force. Here is the horizontal component. Here is the vertical component. Okay, so we see here this triangle. It's a right triangle. The right angle is here between the two components. And the 30-degree angle that they're giving us is right here. So if I wanted to break up that triangle, if I wanted to see okay, if the applied force is 90 newtons, how much of this is to the right? How much of it is down? So the x component of that force, I'm going to find that by multiplying the magnitude of the applied force at 90 newtons times the cosine of 30 degrees. Okay, so go back to SOHCAHTOA. Cosine is the adjacent over the hypotenuse. So usually for our horizontal components, we're using cosine. And then for the vertical component, we are multiplying the applied force times the sine of 30 degrees. So in general, that's how we're going to deal with an angled force. We have to break it up into x and y components because with force being a vector quantity, we really have to make sure that we're separating and kind of grouping together vertical things with other vertical things and horizontal things with other horizontal things. So when we're answering the first part of this question and we're determining the acceleration of the mop, okay, we're thinking this object is being pushed to the right. The direction of its acceleration will be to the right. So I'm dealing with horizontal forces and components of force when I'm trying to solve for acceleration. So if we want to find acceleration, we have to write a net force equation for our horizontal forces and components of force. So we're kind of just starting off with this idea that our net force on the x-axis is equal to the x component of our applied force minus our friction force. We're not worrying about any vertical forces or components of force with acceleration because this mop is not going to be accelerating upward or downward. It's only going to have horizontal acceleration. So we're replacing, per Newton's second law, net force with mass times acceleration. We're going to take that x component of our applied force, which we've written an expression for that, minus friction, and solving for acceleration. We're taking our 90 Newton applied force, cosine 30 degrees, minus our 70 Newton friction force, and we'll divide that by our 2.5 kilograms of mass. Okay, so what do we get here? So 90 newtons times cosine 30 minus 70 divided by 2.5 gives us, what's my calculator doing? Gives us about 3.2 meters per second squared. All right, so there's our acceleration. We found that again just by finding the x component of our applied force, subtracting friction, and dividing by the mass. So now the second part of our question is asking us, well, if we want to determine the magnitude of a normal force on the mop, how are we going to do that? We're going to deal with the vertical forces and components of force. So in this case, we want to write a net force equation for all of our vertical things. So if we are going to do that here, we'll take into account that our normal force points upwards, so we'll keep that in there as a positive value, but the y component of our applied force points downward, so we're going to subtract that component and also subtract the gravitational force because it points downward. So we want to pay attention to the directions of the forces and components of force. So unlike our horizontal components of force, we have no acceleration vertically, so we can set this equation equal to 0 and rearrange that so that our normal force is equal to the y component plus our gravitational force. We'll go ahead and substitute in our expression for the y component and an expression for the gravitational force. So we have 90 newtons times the sine of 30 degrees plus 2.5 kilograms times 9.8 meters per second squared. And we can come up with our normal force here, and that comes out to be about 69.5 newtons for our normal force. All right, guys, so I hope this helped you out here just as an example to show you if you have angled forces, what do we do with them? We want to break them into components. We want to make sure that we are finding our horizontal and vertical components and applying them in the correct places in our net force equations, making separate net force equations for horizontal and vertical components to solve for our unknown quantities. So if you're interested in other videos like this, if you're looking for other videos to help you out with AP Physics 1 topics, we're talking a lot about Newton's laws right now, so make sure that you subscribe, get those notifications, because we're going through a lot of step-by-step problem solving and important AP Physics 1 concepts. And if you have any questions about this topic or any similar types of questions that you're having trouble with, leave a comment. Let me know what you're struggling with, and I might come out with another video that's going to help you out with your specific problem. I'm always reading those comments to see what you guys need a little bit of extra help with to kind of guide the videos that I'm making here. So leave a comment, leave a question, and I'll see you next time.